Hi guys, Unit 3, Lesson 3, Reflections about the X-axis. This one's pretty easy, thank heaven. Transformations when a negative sign is applied. That is the whole concept of the lesson today. And yeah, I just put pictures of kitties because that's what I felt like. This has one simple concept to cover for the whole lesson. I wish every lesson was like this. So first we need to discover a pattern. You can use the functions y equals f of x, which is equal to x squared, and y is equal to negative f of x, which is equal to negative x squared, to determine the transformations. So step one is create a table for each function using the same inputs. So we have a table for y is equal to x squared and y equals negative x squared. Okay, and then they have both tables have negative 2, negative 1, 0, 1, and 2. Okay, we're going to go through and we are going to find out what our y coordinates are for each of these. So we're going to use this formula. We're going to plug in our x value and find our y value. So y is equal to, our first x value is negative 2. We'll put that in parentheses because the negative is stuck to it, and we're going to square it. Negative 2 squared is equal to positive 4. So there's how we find our first number. Okay, I'll do it over here for this one. Y is equal to negative x squared. So y is equal to negative, and our first x value is negative 2. And we're going to square that, okay? Negative 2 times negative 2 is positive 4, but we still have our negative, so this becomes a negative 4. That's how you find it for the whole table for both sides, okay? We've done this a lot. I'm just going to move on. If you need help with this, please comment, can you finish the tables on the Discover a Pattern page? So this is what happens when you've got the tables filled out. So evaluate each function for the inputs and determine the outputs, and compare the outputs for each table. What transformation occurs when the x values stay the same but the y values are opposites? So here for the y values we have 4, 1, 0, 1, 4. Here we have 4, negative 4, negative 1, 0. This should be negative 1. I apologize, I mistyped there, and negative 4. So what you can see from this table, these two tables, is that when you change the value, the function from positive x squared to negative x squared, all of these x values still stay the same, but the y values just become their opposite. So positive 4 becomes negative 4, positive 1 becomes negative 1, 0 isn't positive or negative, so it stays the same. Positive 1 becomes negative 1, positive 4 becomes negative 4. This is what it looks like when it's graphed. This is the original one. It's a positive parabola. And the new one that's a negative x squared is a negative parabola. Okay? The graphs are reflections of each other. Specifically, when y equals negative f of x, it's a reflection over the x-axis of the original function y equals f of x. The x-axis is the line of reflection for the graphs. It is where you can fold the image to make the two graphs match. If you've ever cut out a paper snowflake or a heart, when you fold the paper in half and you cut out half of the heart and then it makes a perfect mirror image, a perfectly symmetrical heart, this is the same concept. I could fold this paper right along the x-axis and these lines would line up exactly because it's a perfect mirror image. Nothing changed except it flipped upside down. Here's a check-in. What is the general name for changing the position, size, or shape of a graph of a function? A transformation. Okay. Example number 1. What type of transformation occurs with y equals f of x when y of f of I can do this, f of x is equal to the square root of x? So the first step is to create a table for each function using the same inputs. So we have f of x is equal to the square root of x, and f of x is equal to the negative square root of x. Use the same x values, 0, 1, 4, 9, 16. The reason we're not using like negative 2, negative 1, 0, 1, 2 is because we're dealing with a square root. We need numbers that have beautiful square roots. So the square root of 0 is 0, the square root of 1 is 1, the square root of 2 is 4, right? 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Okay, that's where these numbers are coming from. X values are the same on both sides, on both tables. Okay, plug these x values into the formula and we end up with 0, 1, 2, 3, 4. And then when we put a negative in front of it, we end up with the opposite. So 0, negative 1, negative 2, negative 3, negative 4. We saw the same pattern with the last formula we used. Step 3 is to compare the outputs for y equals f of x and y equals negative f of x. Although the inputs x values are the same for both functions, the outputs y values are opposites of each other. Therefore, this must be a reflection over the x-axis. So when you have the same x values and then opposite y values, one's positive, one's negative, you have a reflection over the x-axis. Okay? This is the only thing we're talking about today, but this is important and should go in your notes. A reflection over the x-axis. These are the same, okay? These are opposites. This one's positive, this one's negative. Recall that when reflecting a figure or graph over the x-axis, the x values remain the same and the y values become the opposite of the original figure or graph. Get this in your notes. You'll want it later. Not necessarily for this lesson, but at some point this will come in handy. Here's another check-in. What transformation occurs to y equals f of x when a negative sign is placed in front of f of x? A reflection over the x-axis. This is another way of stating the same thing. He's sticking his tongue out at you. Interactive question. Match each point to its reflection over the x-axis. So if our first point is 5, 4, the x value stays the same, so we need a positive 5, and the y value becomes negative. So there's our first matching set. For negative 4, 5, the x value stays the same, so here's our negative 4, and the y value becomes opposite. It becomes a negative 5. This one, our x value stays the same, so we have our negative 5. Negative 4 is going to become opposite, so it becomes a positive 4. Our last one, the 4 is going to stay the same, and the negative 5 is going to become a positive 5. So that's how that lines up. It's that easy. Don't change the x, flip the sign on the y. Okay. Here's question number 1. And here's our little kitty to remind you that this is your turn. You're going to do this without me and then come back. Complete the table of values for the function f equals the square root of x plus 4 and its reflection over the x-axis. So here's your two tables. We have x with the same values on both tables. We have y equals f of x, which is going to be this first formula, and then y equals negative f of x, which will be negative here. Okay? So go ahead and pause the video, figure it out, come back, we'll do it together. Okay, so our formula for right here is going to be y equals the square root of x. Oh my goodness, I can't write today. Plus 4, okay? Which means over here our formula is going to be y equals negative. Whoa! That was beautiful. Let's fix that a little bit. Y equals negative. Oh, it changed my color. Let's get back to black. Whoop. And now you're going to put a parenthesis and put the rest of this formula, which is the square root of x plus 4. Okay? Now, this can also be written another way. If we distribute this negative out, this can also be written as y is equal to the negative square root of x minus 4. You can't really see that because I'm so talented, but that's another way to write that, okay? If you didn't get this part of it right, pause it, go back to it right, and then come back and fill out our tables, okay? Let's get our pen color back to black because I prefer black. I'm feeling like black today. Let's do this first. So we have y equals the square root of, our first value is 0 plus 4. The square root of 0 is just 0, so this is going to be y is equal to 4. Punk, punk, punk. Okay, let's do this next one. Y is equal to the square root of 1 plus 4. Okay, I'm just plugging this x value in here and using the rest of the normal formula. So that's going to give us y is equal to, the square root of 1 is just 1, so 1 plus 4, which is 5. Okay. We're going to continue down and fill out this whole thing. Now we have 4. Y equals the square root of 4 plus 4. The square root of 4 is 2, so that becomes 2 plus 4, which is 6. Okay, let's erase some of this garbage so I have some room to work. Okay, we're going to do 9 now. So we have y is equal to the square root of 9 plus 4. The square root of 9 is 3. So 3 plus 4 becomes 7. Now we have y is equal to the square root of 16. This is why we're using those weird x values, so we can get nice, pretty square roots. Okay, this becomes 4 plus 4. So our next value is 8. And finally we have 25. Y is equal to the square root of 25 plus 4, which becomes 5 plus 4. And now we have 9. Now what we have been taught is that when you have f of x is equal to, y is equal to f of x and y is equal to negative f of x, that all of these values should just be flipped. So this should be negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. We're going to test that theory, okay? So we have y is equal to negative square root of our first value, which is 0, minus 4. I'm using this formula right here, okay? So that means we have a negative 0, which is just 0, minus 4. So look at that. We do have a negative 4. Okay, let's come down here and try number 4. Y is equal to the negative square root of 4 minus 4. The negative square root of 4 is negative 2. Minus 4 gives us a negative 6. Look, it's still holding. Let's try our last one. Y is equal to the negative square root of 25. Now remember, because this negative is outside of the square root, it's going to stay no matter what happens under here. Okay, so this becomes negative 5 minus 4, which becomes a negative 9. It held true for all of those, so we can assume that this is going to be negative 5, this is going to be negative 7, and this is going to be negative 8. Work smarter, not harder. Don't fight through the whole thing. So we have 4, 5, 6, 7, 8, 9, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. They match. Okay? Easy enough. Question 2. This is all you. Look at our little kitty. Sketch a graph of the function y equals f of x equals x minus 3 squared and y equals negative f of x. So pause the video, go do it, come back. Okay, so the first thing you need to do is make a table of values. So we have y and, nope, sorry. I'm doubting myself and I shouldn't for once. We have x and we have f of x for our first table, right? Chunk. Okay, we'll get our values down here. And then we'll have x, and I'm just going to combine them into one table. I hope I'm not confusing you, but the x values are going to stay the same. But over here we're going to have negative f of x. Okay. I'm just out of room, so I'm going to make one table. So let's see here. We're going to have x minus 3, and then we're going to square that. So I'm going to cheat and go look and make sure I'm thinking right on my x values. I think we're going to have those square values. So like 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4. I think those are the ones I'm going to go check. I was right. Oh my gosh, I'm going to have to edit it now because I'm a moron. Okay, so we have 0, 1, 4, 9, 16. Okay. Let's chunk. I'm so good at drawing lines. Okay, so here's our formula right here. F of x is equal to x minus 3 squared. So we're going to change the f of x to a y. We're going to say y is equal to, our first x is 0, so 0 minus 3 squared. Okay, so 0 minus 3 is negative 3. The negative stays in the parentheses, so it's part of it. Negative 3 times negative 3 is positive 9. So our first point is 9. Which means over here, it's going to be negative 9. Don't overthink it. Okay, let's do 1. So we have y equals 1 minus 3 squared, which is going to give us a negative 2 in parentheses. Squared, negative 2 times negative 2 becomes positive 4. So we have 4 and negative 4. Okay, let's do 4. Y equals 4 minus 3 squared, which is going to give us 1 squared, which is just 1. So we have 1 and negative 1. And then we have 9, which is going to give us y equals 9 parenthesis minus 3 squared, which is going to give us 6 squared, which is 36, and negative 36. And here's the big one, 16. Y equals 16 minus 3 squared, which is going to give us 13 squared. And boy, howdy, am I getting a calculator for that one. Let's go 13 times 13 is 169 and negative 169, which I'm not going to try to skirch in there, okay? Then you're just going to go ahead and plot it. Now, here's a lovely little thing. If you use GeoGebra, you can just plug in the two formulas. So y equals x minus 3 squared and y equals negative, and then so negative x plus 3 squared. And it will graph it for you. But you can also go ahead and make your own little graph. I will show you how to do that. I'm not going to bother doing the 36 and 169 because that's kind of insane when, you know, I'm drawing a graph by hand. But we have our graph right like this, chunk, chunk, okay? So our first point is 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's our first point, okay? And then we have 1 and 4, and then we have 1, 2, 3, 4, and 1, okay? And then, so we've got a parabola, whoop, it's kind of like this, okay? And then it's going to go whoop, okay? And then the other one's going to come down here and go whoop, except it's touching the line because, you know, I can't draw. So this is what it's going to end up looking like. Okay? And we can double check. It's crossing through the point 0, 9. Let's check. Here's 0 and 9. Oh, look at that. It did. Right there. And 1 and 4. Right. Okay. So we did it right. This is what it's going to look like. It's not going to ask you to graph anything on the end, so don't stress too much about this one. Okay, practice question number 1. This is at the end of the lesson, so just solve it, write your number down, and then you could plug it in when you get to this point in the lesson. Based on the tables, which of the following options is a true description of the graphs of f of x and g of x? Here's f of x, here's g of x. Let's look first and see what we can determine. So, well, you pause it and then come back. I will do that. Okay, so first of all, we can see all of the x values are the same. Okay, the y values, look at that. They're all opposite. So if these are the same, and these are all negative, and these are all positive, what does that tell us? One graph is a reflection of the other over the x-axis. That's the only thing we've talked about this whole lesson. We didn't talk about the y-axis, so it can't be this one. And we didn't talk about the origin, so it can't be this one. And it would have to be this answer anyway, or else it wouldn't make sense. Okay, practice question. This is 2. I got them out of order, I think. I apologize. If the point 3, 4 is on the graph of y equals f of x, what point must be on the graph of y equals negative f of x? You shouldn't even have to pause this to figure out which one of these is going to be on the mirror image, the reflection over the x-axis, if this one exists. Well, the x number stays the same, and the y number, the sign gets flipped, so it has to be this one. Don't just click option 3 because they shuffle these, okay? This is quick check number 1. I won't give you the answer, but I'll tell you how to find the answer. If the function f of x equals x plus 3 squared is reflected over the x-axis, then how does the reflection affect the point 225? This is literally what we just did. One number stays the same, one number has the sign flipped. Figure it out over here and write your answer down. Quick check question number 2. Which table shows that y equals negative f of x results in a reflection over the x-axis? So this is kind of irrelevant. You don't really need this, but it's going to make, well, I guess you do need it. It wants to know what points we need to make that reflection over here. So you need it because you need to know the points here. So remember, one, either x or y stays the same, and the other one, the signs get flipped. Okay? So you should have all of the same numbers. You should still have a 2 and a 0, and a 3 and a 1, and a 6 and a 2. So all of these are viable options. But one of the sets of numbers stays the same and one gets an opposite sign. Figure it out. Quick check question number 3. Choose the correct statement to describe a true relationship between any point on f of x and negative f of x. Okay, you can do this. I believe in you. You can do this. This is all the same question over and over and over and over, worded in different ways. Okay, describing a reflection over the x-axis. When given the graphs f of x equals x squared and f of y equals negative f of x, what do you notice? First, the new function is created by flipping the original function over the x-axis, flipping the image upside down, folding that paper, however you want to think of it. All of the x values stay the same. If I have a 0 here, I have a 0 here. If I have a 4 here, I have a 4 here. Okay. While all of the y values become their opposite, multiplying all the outputs by 1. This is a positive 4, and this one's a negative 4. Okay, we have all the same numbers, but the y values get flipped to positive and negative. If you examine the points from the original function to the transformed function, you will notice that the change in the y values. On a grid, you use the rule xy becomes x negative y for a reflection over the x-axis. Keeping in mind that y equals f of x, you can also write this rule as x f of x is equal to x negative f of x. Okay, this should go in your notes for future reference, not even for this lesson. I mean, by this point you should know this. Example number 1, describe the function transformation of f of x equals x squared minus 4x plus 2 to y equals negative fx, f of x. What are the similarities and differences of the graphs? We'll go through this together. Okay, the graph of the function f of x equals x squared minus 4x plus 2 is flipped over the x-axis. Okay, this flip creates a mirror image of the curve. The equation of the function of the reflected image is y equals negative f of x equals negative x squared minus 4x plus 2, or negative x squared plus 4x minus 2. They just took this and distributed it out. So the positive became a negative, the negative became a positive, the positive became a negative. In the graph of the reflected function, only the y-coordinates are changed. The x-coordinates remain the same. Okay, so right here we have a negative 1, and it crosses, you can see it crosses right there. Okay, and guess what? Right here we still have a negative 1 for the x. Okay, the negative 1 did not change for the x. Both graphs represent quadratic functions with the same x-intercepts. However, the original graph has a minimum value. Okay, so this one has a low point, this minimum value of right here. Okay, that's what it's talking about, of y equals negative 2. Okay, the reflected graph has a maximum value. It has a high point right there of y equals positive 2. Okay, this isn't correct, ignore that. Okay, so they flipped, but at this point they're not touching where they flipped. It got flipped because of this shift, because of this part of it. It got shifted up because that's what has to happen to make a correct mirror image. Okay, here's a check-in. Describe the term reflection over the x-axis by using the graphs. Okay. Describe the term reflection over the x-axis by using the graphs. A reflection I'm allergic today. A reflection over the x-axis is demonstrated by graphs A and D. A got reflected over the x-axis to become D, as well as by graphs B and C. Both pairs of graphs show functions that have the same x values and negated y values. Okay. Example 2, identify which graph is a vertical reflection of y, this orange one right here. Y equals x plus 2 squared. Which one of these is a vertical reflection over the x-axis? The same thing we've been doing all this time. It's obviously B, because we're not going side to side. That's wrong. No, no, no. We're going up and down. Okay. Here's another check-in. Give an example of a parent function and a vertical reflection of the parent function. Describe the changes in the reflected function. So an example of a parent function is y equals x squared. And the vertical reflection of this function is y equals negative x squared. The y values of the reflected function become opposite to those of the original function. If you feel like this is repetitive, it is, okay? This lesson is covering one thing over and over and over and over. Question 1, your turn. What happens when a function is transformed from y equals f of x into y equals negative f of x? Answer it. You should know by now. The transformation is a vertical reflection of the original function. The vertical reflection is a reflection over the x-axis, so the function is reflected over the x-axis and mirrors the original function. This transformation makes the y-coordinates change to the opposite, so xy becomes x negative y. Okay. Here's question 2. This one's all you. Identify which graph represents y equals negative f of x when y equals 2x plus 3. So this is our original line, this orange one. Which one of these is the reflection over the x-axis? Oh, the negative reflection. Oh my goodness. Okay. Pause it. See if you can figure it out. They haven't showed us one like this yet. Okay, so you have to remember all of the x coordinates stay the same. It's not going to shift over here to b. It's going to be a. All it did was shift from a positive line to a negative line. Okay, has the same slope, has everything else. It's not b. B is ugly. We don't like b. Okay. Practice question number 4. We're at the end already. Given the graph of f of x is equal to x plus 3 squared, which of the options is the graph of y equals negative f of x? So this orange one is our original. Which one is the vertical reflection? You should be able to tell pretty easily. It's option 2. Okay. Here's practice question number 5. Given the graph of y equals f of x, which of the following options is the graph of y equals negative f of x? Okay. So we're dealing with this one right here, which is the vertical reflection over the x-axis. D. Okay. I won't answer this one for you. This one's you. Given the graph of f of x is equal to x plus 1, which of the options is the graph of f of x? So our original line is this orange one. Which one is the correct reflection? You can do this. I believe in you. And quick check question number 5. What happens to the x-intercepts of the function y equals x squared minus 25 when the graph is reflected over the x-axis? Explain. Same question it's been asking over and over and over and over and over and over and over. You can do this. I believe in you. Kitty cats make me happy.